Digital Twin Forest is a cutting-edge software application that integrates real-world models of forests and their associated data to provide users with valuable insights for forestry research and management. This is the main page of Digital Twin Forest. Users can access the forest scene, instruction page, contact us page, and update data page. The background of the main page is designed to match the topic of the product and provide a pleasant user experience. This is the Contact Us page, where users can access to the information about the individual members of the development team. This is the instruction page of the application. As you can see, the instructions are clear, concise, and easy to understand. Users can press WASD to move around. The camera is connected to the mouse, allowing users to change the perspective of the camera. If users want to click the buttons on the screen to show the data without moving the camera, they can press P to disconnect the mouse from the camera. Additionally, a function is provided to centralize the cursor for users who wish to see a wider perspective. Returning to the main page, by clicking on the Start button, users can enter a virtual forest that serves as the main scene of our software. Here, users can interact with the Digital Twin Forest and analyze data. We can move around with the cooperation of keyboard and mouse. As you can see from the bottom left corner, the FPS is stable at about 50, which can provide users with a smooth experience. The system can also be paused by pressing P. When the system is paused, the mouse and camera are disconnected. This is very convenient for users to click buttons to check environmental data and tree parameters. At the left up corner, we have a button to demonstrate the environmental data for a specific plot. After clicking it, a window will show up with environmental data, including humidity, temperature, soil carbon content, soil nitrogen content, and leaf area index. At the right up corner, we have a button to show tree parameters. After clicking it, a window will appear on the screen's right side, demonstrating different tree parameters, including tree density, DBH, height, and age. Here, we have a switch button. After clicking the switch button, a pie chart will show up illustrating the ratio between different tree species, including red pine, oak, beech, birch, red maple, white pine, and red oak. In this way, users can clearly understand tree species distribution. Also, by changing the tree type, the tree parameters will also change according to the specific tree species. In addition, we can now click on the Environmental Data button to see the environmental data for each plot. Notice that if we change the plot, the environmental data will change as well. For the virtual forest, the trees are modeled based on real-world data. Different parameters will result in different models. For example, we can switch the plots to see how tree distribution changes based on different parameters. If the users move up to see the forest from top, it is clear that the tree distribution is quite different. Moreover, when we click on the Seasonal Change button, the season will switch between summer and winter. All leaves are gone in winter, except the pine trees. We also add snowing effect to the scene, and the snow can fall on the surface of terrain. Now, we can go back to main page and click the Update button. We can update environmental data and tree parameters here. After that, we can observe the changes are reflected on parameters and models if we go back to the forest. An example we are presenting here is modifying the height of trees in real time. To demonstrate, we update the height of pine tree in plot 1 to 50 meters. We can then return to the forest and observe the difference. As a result of the change, the pine tree is now noticeably taller than the other trees. An additional instance of modification is to adjust the density of a particular tree species. For example, in plot 4, 70% of the trees are birch. By updating the density of birch trees in plot 4 to 0, we can observe in the forest that the birch trees characterized by bright yellow leaves have been removed from the terrain. In conclusion, Digital Twin Forest represents a promising application of technology in the field of environmental science research. Also, an exciting demo of the non-artificial part of Digital Twin Earth. From here, we have access to a broader view. Imagine having access to a virtual replica of the Earth that can help us predict and mitigate the impacts of climate change, manage natural resources more efficiently, and optimize urban planning and infrastructure development. That's exactly what Digital Twin Earth offers, a comprehensive and integrated view of our planet, created through the integration of vast amounts of data and cutting-edge simulation technology. That's a part of the solution to some of the most critical challenges facing our world today. Together, we can create a better future for ourselves and for generations to come, from a forest to a planet.